truth. It's so true.
All right. So I know a lot of you do like this way. If you do it this way, okay, just do it right. The reason I like this way better is because there's absolutely zero guessing. I can just see that the cube root of this is this. I mean, it's just there. I see why things are where they are. This is very amorphous, right? I love that word. Very weird. A colleague of mine is trying to figure out, like, square root is a jail cell, and it takes two people to get out of it. One person distracts the guard, and the other one actually gets out. So a cube root is like a higher security prison. An 11th root would be like crazy security, so you need 11 people, 10 to do this, and then one person makes it out. You guys get that a little bit? I'll figure it out. So we did the square root of 50. I'm going to do it the way that I really, really, really prefer you guys to do it. Square root of 25 times square root. Why did I pick 25 instead of 5 and 10? Because 25 is a square, and it is a square root. So if I have a cube root, I try to break it down using a cube number. 1, 8, 27, 64, 125, holy shit. Okay. Square root of 25 is 5. Square root of 2 is, I don't know. Square root of 72, the direct way to do this is square root of, is 36 times 2. Well, let's pretend like you didn't see that. Let's pretend like you saw 9 and 8, right? So you get 3 square root of 8. And if you circle that, you're wrong, because 8, 3 times square root of 4 times square root of 2, right? 8 is 4 times 2. And then square root of 4 is 2 times 3 is 6. So that's why I don't like, see how I put that in parentheses, bring out? You don't bring something out of the root. Just the square root of 9 is 3. You don't bring a 3 out. It doesn't make sense. But whatever you bring out, if there's something already out there, you multiply it. Why? Because everything's multiplying. That's why.
Where did the 6 come from?
What's the square root of 4? And times 3? Yeah, okay. Now this guy, what square number goes into 120? Yeah, 4 goes into 120. That's a good place to start. This would be the square root of 4 times the square root of 30. What's the square root of 4? 2. Does a square number go into 30? No, 4 doesn't go into 30, 9 doesn't go into 30, 16 doesn't, 25 doesn't, 36 is too big, shit, so I stop. There's multiple reasons why I prefer that method. But the other method works if you do it correctly, but oh my god, there's a million different ways to make a mistake on that shit. Number 4 is another one that you can do in multiple steps. I saw most people doing 4 times 20, like that, right? Become a 20. Oh my god. Very good job. Square root of 4 is 2, but 20 is also square root of 4 times square root of 5. God, I had a weird feeling. If I turn around, there'd be nobody. I'm like, oh shit. What happened to everybody? Square root of 4 is 2. So I end up with 4 square root of 5. Now, some of you guys might have realized that 80 is 16 times 5, and the square root of 16 is 4. See how we end up at the same place, with the 5 left inside. Total trip. All right. This one you leave, because it doesn't have enough stuff. It's got 1, 3, and 1, 11. It's got nothing. It doesn't have enough. So it's already simplified. You know that's going to happen sometimes. Cube root of 64, you should know that. That's an easy one. I just gave you an easy little softball. Yeah. That's 4. Done, right? What about this guy, though? It's a cube root, so what numbers do I try to divide into 40? 2 cubed is 8, so does 8 go into 40? Yes. So I can rewrite this as the cube root of 8 times the cube root of 5. Cube root of 8 is 2. Cube root of 5 is, I don't freaking know, right? And just to make it not look like a 2 cubed, you could do like that. Don't forget your cube root. It can't suddenly transmogrify into a square root. It has to stay the same root. Transmogrify. Look that shit up. If you read Calvin and Hobbes, your vocabulary would explain. Yes?
Can you explain that again to me? If I just skip those over.
Which part?
On the first page.
So, to do it the better way, it's a cube root, so you try to break 40 down into a cube number times something. I wouldn't use 4 times 10, because it's not a square root. 4 doesn't help me out your worst shit. If it was a square root of 40, then I would do 4 times 10. Because then I can do the square root of 4. 4, I can't do the cube root of 4. I need the cube root of 8. And thankfully 8 goes into 40, so I can break it up. As a cube root is something I can do, times a cube root is something I can't do. And then what do? I do the part I can do. I leave the part that I can't do. Sounds like a life philosophy. Number 8. Does 8 go into 54? No. What's the next cube up? 27. Does 27 go into 54?
Yes.
Yes. How many times?
Twice.
Twice. So that I could break this up as cube root of 27 times cube root of 2, because 27 times 2 is 54. Now I can do the cube root of 27 is 3. And the cube root of 2 is, I don't freaking know. So it's 3 cube roots of 2.
So you're trying to find, like, when you were looking for 27, like, what were you looking for?
It's a cube root, so I'm looking for a cube number. What are my cube numbers? 1, 8, 27, right? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. I like it. So you have to at least know it to 5, I'd say. That's what you're looking for when you have a cube root staring you in the face. What about number 9 then? What's number 9? Yeah, 8 definitely goes into that shit. Right, so this is cube root of 8 times the cube root of what?
111.
111. Is 111 a prime number?
Yes.
No.
No?
What's 1 plus 1 plus 1? 3. Do you guys remember, didn't I tell you this earlier? If you add up all the digits and it's divisible by 3, that means 3 goes into the actual thing. 3 goes into 111. How many times? I don't know. 33, 34, 35, 36,
37.
37. I'll get there eventually. What did I do? I went 33 makes it 99, and then tried to get up to 111. So cube root of 8 is 2. Cube root of 111 I can't do. So it's 2 times the cube root of 111. And the last one is easy. I can't do the cube root of 100. There's not 3 anything. There's a 2 and a 5 and a 2 and a 5. If it just was 1,000, then I could do the cube root, because 1,000 is 10 times 10 times 10. 100, there's not enough stuff in there, so it's done. I can't do anything with it. Woo! I love you guys. Every now and again, you're like, oh my! All right. Don't get too excited. We're not done. Now I want to immediately show you 2 things here coming off of this idea. Here's something a little. When I bring variables into this kind of thing, and you know we have to, it's going to kick so much ass if you really understand why this beautiful little shortcut works. So watch this. In fact, we've already done the idea behind this shortcut. How do I do this? Right? Don't we do 4 into 44? We break 44 up into 4 parts, right? So this would be, what would the answer be? Don't worry about absolute value shit. We'll say it's all positive shit, right? So this would be a to the 11. Okay. Because 4 goes into 44 11 times with nothing left. What if it was a 4th root of a to the 45th power then? How many extra a's are in there? 1. There's 1 stupid extra a in there. So I'm going to do it the long way, and then I'm going to point out the shortcut. So the long way would be sort of related to what we're doing up there. Isn't this the fourth root of a 44 times the fourth root of a? Wouldn't that be a 45? A 44 times a is a 45. Well, what's the fourth root of a 44? A 11. And what's the fourth root of a? I don't know. Now watch this beautiful shortcut. 4 goes into 45 11 times with 1 left. What happens? What's the matter? All right, let me start over. All right, let's try to ask that question a little better. Everybody cool with this one?
Yes.
Okay then. So it's the same way if I know cube root of 8 is 2, I can do the cube root of 40 because I see an 8 in there, right? Same thing we just did up there, right? So if only this was a 44, well, I see 44 a's in there, don't I? So I can break this up as the fourth root of a 44 times the fourth root of a. Okay. So this I know is a 11, and this one I don't know. It's just the fourth root of a, whatever shit that is. And now I'm trying to show you something to save you a little work. The way you've said it ever since you learned division is the way that this gets set up. It's too beautiful to believe. 4 goes into 45 11 times with 1 left. Yes, with 1 left. 1 left where? 1 left inside the root.
That's way easier than that.
Why can't I do that this way?
I don't know.
What's different about the way a variable is written? This has a power on it, doesn't it? Now, if you wanted to take the time to rewrite all those numbers as stuff to a power, you could do it the same way. Do you understand? Why is this way easy? Because there's a power there. So I can do 4 into 45 because those powers will interact with each other. Are those written with powers? No. So this is one situation. I would love what you just said. The variable shit is easier than the number shit, ain't it? You're not used to that being true.
Never.
But why do numbers act differently? They don't. They never do. They never act differently. They are written without powers. That's why we had to do it a different way. Now watch, real quick. I want to show you something. If I take cube root of 40, and I break 40 down into, so 8 times 5, so 2 times 2 times 2 times 5, right? So isn't that cube root of 2 cubed times 5? 3 goes into 3. 3 goes into 3 once with no 2's left over. I mean, so if you write them in exponential form, they will act the same way as these two because these are written in exponential form. The only reason variables seem to act differently is because they are written with exponents and numbers are not. So of course they're going to act different because they're not written the same format. They're going to. Does that make sense?
Yeah.
Is that cool? All right. Okay. Now watch this. So let's take this idea.
Yeah, make one hard. That we're gonna
Not
see
yet.
like the
Hold
whole
on. Everybody's like, shut up, man. But yeah, I want to get there. I don't want to get the first time you see a hard one would be on the test. That would suck. So you shouldn't complain when it makes some hard problems on the board. But not quite yet. Let's do this. What about the cube root of x to the 17th power? Take a second. Don't say anything out loud. The same thing we just did. You don't have to do this step, right? The shortcut. I'd love it if you guys can just do the shortcut. It's the way you've said it forever. It's the way it works. What do I mean by that? 3 goes into 17 5 times, so x to the 5th, with how many left? 2. Done. Isn't there 2 extra x's in there? What number would be nice that's below 17? 15 would have been nice, Jeff. Why you put 17? Well, the 2 extra x's are just there. They used to get left behind because there's only 2 of them and I need 3 somethings to come out, right? Come out. Okay. Doesn't that kick ass? No? Like, I'm not going to say anything kicks ass here, Jeff. Don't get too excited. Okay. So what about the 11th root of x to the 56, y to the 91, z to the 124. Oh, calm down. Those numbers are easy. Give me a break. You guys just kind of double digits? Screw that.
Yeah.
Is it hard to do 11 into 56? Is that really hard? No. So be quiet. I love that immediate, like, no, screw that. No way. No way. All right. So 11 goes into 56 how many times? 5 with?
1 left over.
1 left over. 11 goes into 91. 11 goes into 88, right? So 8 times with 3, because 88 to 91 is 3, right? And then 11, well, 11 squared is, so 11 goes into 124 11 times. It's not 121, it's how much more? 3 more, with 3 left over. Shua! That takes so much answer.
How would this be written if one of them, you just omit it from the root, if it went into it all the time?
I'm not-
If it was D11 in there?
Oh, if it went in evenly. So if I would have had like a, W to the 22nd. Right? Is that what you're asking?
Mm-hmm.
And then so 11 goes into 22 twice with none left. No W's
Okay.
left. Right? Isn't that awesome? The way you say it, ever since you learned division, is the way you set it up here. It's crazy. Okay, so here's the second thing I definitely wanted to show you today. So we got that there. I'm going to start off seemingly a little strange. What is 2x plus 3x? No tricks. Just what is 2x plus 3x? No tricks. 5x. Okay, thank God.
10.
So what is 2m plus 3m? 5m. So what is 2 square root of 2 plus 3 square root of 2? 5 square root of 2. Of course. 2 things I don't know, plus 3 things I don't know, is 5 of those things. Don't put 5 square root of 4. I'm like, where do you see 5 square roots of 4? I don't see any freaking square roots of 4. I see 5 square roots of 2 all day long. Does that make sense? Almost too much to really believe? Maybe? So what's a variable? A number I don't know. What's the square root of 2? A number I don't know. They're going to act the same damn way then. Holy shit. So what about this? What is the, that's example 1. Example 2. What if I had 5 cube root of 7 minus 2 cube root of 7 plus 4 cube root of 11?
3 cube root of
Yep.
7.
5 of these minus 2 of these is 3.
Plus 4, 3 cube root of 11.
4 cube root of 11. Can I put those together? Hell no. I got 3 of these things I don't know, plus 4 of them things I don't know. I ain't got 7 of anything. They're not like terms. This is like 3x plus 4y. So I can't put them, of course I can't put them together. I can only put together like terms. That idea never changes. So, I'm about to put down an equation that I claim you can do something with. Not an equation, but an expression. 4 square root of what, Jeff? I don't know, man. 27, yeah, I like that one. Minus 5 square root of, what? Sure, I like it. Yeah, that's beautiful. Now on the surface, your immediate reaction should be, can you put those together? No. I understand, that's a beautiful reaction, right? But I can do something, because the square root of 27 is not really a variable. It acts like a variable sometimes, but can't I do something now with square root of 27? It's not the cube root, don't tell me it's 3. It's the square root of 27. I can break 27 up into what? So I got 4 times square root of 9 times square root of 3 minus 5 times square root of, now watch this, watch this. In order to be like terms, isn't this going to have a square root of 3? And 3 times what is 48? 16. So I can do 16, 3. Aren't they going to end up being like terms now? This is 4 times 3 times square root of 3 minus 5 times 4 times square root of 3. Is that cool? Just doing the square roots that I can do. So I just did square root of 27 and simplified it. Like we just did on that paper. Did square root of 48, simplified it. What do I get out here now? 12 of these minus 20 of these is negative 8 of these. Done. So they're not like terms, they are numbers. So maybe I can do something. Here I can't do shit if it's letters. 2m plus 3x, I can't do shit. But these are numbers. Maybe I could do something so I end up with like terms, and we do that. Which is one big reason why we learned that. Right? So I can simplify them and see if I got shit I can put together. That, oh shit, that is section, where are you? I think I'm still in 10.3. Isn't that crazy?
But
No.
you just put 10-4 on the board.
What's the matter?
That wasn't from 10-4?
No, it's not from 10.4.
Oh.
It's actually from 10.5. You know the funny thing about 10.4? 10.4 is just dividing radicals. So in order to be able to divide radicals, what must be true about the roots? They have to be the same. The only new thing we got to still do in 10.4, I'm not going to do it today, is something called rationalizing the denominator. Rationalizing the denominator. Salendron. So we'll do that tomorrow.
So that was all from 10.5 though?
That was, this is from 10.5, yes.
Okay.
That's the
Yeah.
next really new thing.
Okay.
Everybody got a practice test, right? So tomorrow I'll have the answer key for the practice test. Tomorrow we're definitely going to make it into 10.6. So the test will be covering through 10.6. Yeah, please, dear God, don't forget to pick up your stuff and give me my colors. Thank you.